Question 15. In part A, we're given that e to the ix is equal to cos x plus I sin x. We want to show that sin x is equal to e to the ix, take away e to the negative ix, all over 2i. E to the negative ix would be cos negative x plus I sin negative x. Now we know that the cosine is an even function, so the cosine of negative x is always equal to cos x. But the sine of negative x, because sine is an odd function, is always the negative of sin x. So e to the negative ix is equal to cos x minus I sin x. So if we do e to the ix, take away e to the negative ix, cos x's cancel, but we end up with 2i sin x, and therefore sin x is e to the ix minus e to the negative ix divided by 2i as required. In part B, we're asked to expand e to the ix minus e to the minus ix over 2i all to the power 5 to obtain an expression for sine to the 5x in terms of sin x, sin 3x, and sin 5x. So that sine to the power 5x is e to the ix, take away e to the negative ix, over 2i to the power 5. And we can do this directly on the calculator.
We want to use the cexpand function, so it's best to make sure that we're in complex mode and check that we're in radians. I also want to be in standard so that I get fractions in the answer. So we want to find cexpand, go to category and C, and then scroll down until you find cexpand. So we have cexpand, which you can also find in the action menu, and then we want to put in our expression. So I'm going to put an open bracket, and then our expression is a fraction. So we have e to the ix, remember the I we need to use is this one, it's going to have 2i on the bottom. Then we have to be careful at the top here that we go beyond this index. So that's now minus, and we have e to the negative ix, close the bracket, and we need all of that to be to the power 5, close the bracket and execute, and we get 5 sin x over 8 plus sin 5x over 16, take away 5 sin 3x over 16.
So that's given us 5 sine x over 8 minus 5 sine 3x over 16 plus sine 5x over 16. If you didn't know the calculator trick, you can still do this, although it is a lot of work for 2 marks. The 2i on the bottom to the power 5 gives us 1 over 32i. So we're left with expanding e to the ix minus e to the negative ix to the power 5. We can use the binomial theorem, and the line of Pascal's triangle that we want is 1, 5, 10, 10, 5, 1. So we get e to the 5ix, take away 5 lots of this one to the power 4 times this one to the power 1, so that's e to the 3ix, plus 10 lots, this one to the power 3, this one to the power 2, gives us e to the ix, take away 10 lots, this one to the power 2, this one to the power 3 is e to the negative ix, and so on. We get 5e to the negative 3ix, and finally e to the negative 5ix. Now it's just a case of grouping, so that's 1 over 32i. We want to have the e to the 5ix, take away e to the negative 5ix, take away 5, e to the 3ix, take away e to the negative 3ix, and finally 10 e to the ix, take away e to the negative ix. Now if we take 2i from this 32i, we end up with 1 over 16 out here, and then this would become e to the 5ix, take away e to the negative 5ix over 2i. This one would be e to the 3ix, take away e to the negative 3ix over 2i, and then this one would be e to the ix, take away e to the negative ix over 2i, and using Euler's formula we should see that this one here is sine 5x, this one here is sine 3x, and this one here is sine x.